Okay, we're going to look at direct proportionality, and although this sounds complicated, it isn't really. There's lots of units where if we multiply 1, so if we go for twice the amount of time, we would expect to go for twice the distance. If we went for 3 times the amount of time, we'd expect to go for 3 times the distance. So this is an example of something which is constantly proportional, and you can represent it as a graph. There's a couple of important points to notice about the graphs. 1 goes through the origin, so it goes through 0, 0, if it's directly proportional. The second thing is that it's a straight line. So if your line goes through the origin and it's straight, then it's directly proportional. There's lots of things which are directly proportional. There's also a number of measures which aren't. So for example, this is a straight line that doesn't go through the origin, and it's the relationship between centigrade and Fahrenheit when you're measuring temperature. Now, 0 degrees centigrade is actually 32 Fahrenheit. So you can't, if you double your centigrade, you can't just double the temperature in Fahrenheit. It's more complicated than that. Also, here's your scale of wind speed. So 12 is a hurricane, but actually it's not a straight line. It doesn't go through the origin, so you can't, if you double the scale of wind speed, you're not actually doubling the number of kilometers per hour. So you can't just double. Straight lines through the origin, you can double. Okay, so here's an example. We've got an aeroplane travelling at constant speed, so it's a straight line that goes through the origin. Question is, how far does it go in 7 hours? So what we're going to do is we're going to look at what units are nice and easily on the grid points. Well, here we can see that in 5 hours it's gone 4,000 kilometres. So here I've got 5 hours, 4,000 kilometres. So it wants to know how far we get in 7 hours. Well, we should be familiar with this. We're going to simplify it first. So in 1 hour, divide by 5 gives me 800 kilometres. So in 7 hours, times by 7, I would do 7 times 800, which is 5,600 kilometres. So in 7 hours, my aeroplane would have gone 5,600 kilometres. It asks for the equation of the line, or for a formula connecting distance and time. And I'm going to use this. For each 1 hour, I've gone 800 kilometres. So I want to know, if I know my time, how do I get to my distance? Well, here's my time. Here's my distance. Well, what have I done? Well, 1 hour gave me a distance of 800. 7 hours gives me a distance of 5,600. So I take my time, I times it by 800, and that's going to give me my distance. So giving it as a formula, d equals t times 800, or distance is 800 times time. Okay, pause the video now while you write down those worked examples, and then we're going to have a go at some questions. Okay, just 2 questions for you to try with 3 parts in each. Set it out as we did in the worked example. Pause the video now while you have a go at the questions, and then when you're ready, press on pause to get the solutions. Okay, so here are our solutions. So 5 days gave us 180, so 1 day was 36, so 3 days would have been £308. 7 days would have given you £232, and you multiply your number of days by £36 to give you the cost. Part 2, a bit more complicated here. So we put it in simplest form, which was an extension of 1 to 45. That didn't get me down to 54, so I had to do a bit of muddling around here. Dividing it by 5 there. 45 divided by 5 gives me 9. 1 divided by 5 gives me 0.2. And then I times by 6, and I got an answer of 1.2 centimetres from a 54 Newton force. Had to, again, a bit of jiggling around here, you can see above, gave me 112.5 newtons. To go from my force to my extension, I had to divide by 45, so extension equals force divided by 45. If you need any more assistance on that, please take a look at direct proportionality on Hegarty. Well done.